the class? Oh, thank you. Thank you,
Yeah.
Madhu.
Don't want to forget it this time.
So I want to confirm if there are any new students in the class, and if there are, I just want to have a chance for them to introduce themselves. Are there any new students? Madhu, can you see anybody? Because I've not got the screen here.
I think we have been introduced to everyone else.
Okay.
Ajay, I don't see it. I just I'm not sure about Jayapriya Yuvaraja. Were you in the last class? Jayapriya Yuvaraja, are you there? But I think otherwise all the other
I'm from India, Ratnagiri, near Vellore, sir. I'm Kovida student. I'm interested in astrology, so I joined.
okay.
Okay.
Thank you. Thank you and welcome to the class.
Okay, so then the intent is to go through the course a little bit. So in terms of introduction to the contents and the sequence of the lectures and what is going to be any assignments during the period. And we'll then go on to the first lecture as such, which is going to be based on understanding the current state of affairs, the Western understanding, the current scientific understanding of the cosmology that is there before we go into the ancient Indian systems. So yeah, so these are the contents of the course, and I mean, both of us will go through that, and the intent of the course is to uh, basically pass on the knowledge that was developed through a number of years and thousands of years in the area of astronomy. There is a lot of knowledge that's been developed and in the entire system, which is now called the Indian knowledge systems. But we will obviously be concentrating on the astronomy aspect of that knowledge, and we will go through all the different sources that actually tell us about what and how, first of all, how antique, how ancient the knowledge system was, and the actual contribution, actual development, and the advancement of the thought. So we'll also go through different texts of the astronomical wisdom within the system, and we'll actually look at a lot of the actual observations made in those texts, which led to the current level of understanding. Madhu, you want to add?
Yeah, I just wanted to add that you see, it's a very broad-based course. We'll cover a lot of topics, starting from the origins of Indian astronomy until the more modern developments in Indian astronomy. Uh, so it is going to there will be a lot of fundamental concepts that will be covered in the class, which some of you might already be aware of. So in case you feel that it's we'll obviously try to throw a different perspective onto it based on our understanding. but you might be already familiar with some of the concepts that we will actually be talking about, and some of them obviously will be new to you. So I just wanted to kind of set that expectation that it's going to be like a broad-based course covering. So the breadth is going to be there. We will not go very deep into in the different topics that are there. But it's supposed to be more of a broad course. Manish, the question.
So I see Mahesh has raised his hand. In general, what we're going to do in this course is that we will actually try to have the questions towards the end of the class. So we'll come to the whole structure as well. But is there anything quickly
Yeah,
you want to say,
yeah,
Mahesh?
yeah. It has nothing to do with the course. Thank you. So my point was that the gentleman in ASK4, so there's no name written, so I don't know
Oh,
the name.
he's the co-teacher, Madhu.
Ah, Madhu.
Yeah.
Okay. So Ajay ji, your voice is very clear, whereas Madhu's ji's voice uh, modulates quite a bit and it trails off. Maybe something to do with the audio, so I thought I would let you know.
That is a good point, and yes, Madhu, your voice is a little bit unclear today.
Okay. Let me fix that while Ajay is
Okay, sure.
No, there's a lot of echo. There's a lot of echo coming from Madhuji, so that's the reason. Whereas Ajayji is very clear.
okay. Let
I don't know whether you are using different microphones or different type of microphones, or like Zoom versus laptop or whatever.
Yeah, yeah.
just let me fix that, please. So Ajay will actually be doing most of the talking, so hopefully it shouldn't be a problem. But I'll fix that in a little time.
Okay. All right. So the entire idea of the course is to pass on this knowledge of understanding that was developed in the past, and that is essentially the level of uh, understanding or appreciation that needs to be fostered, I suppose, in the Indian population. So that is the aim of the course uh, to actually understand what had happened in the past and what was the level of advancement. Okay, so 1 second. Yeah. So this is the general schedule of the course that we will obviously have it every week at this time. We will have uh, around 15 minutes of lecture. I mean, today will be a little bit shorter because we are introducing the course and so on. But in general, there'll be 15 minutes of lecture or knowledge sharing, whatever you want to call it. And that will be followed by about around 10 minutes of Q&A with every session. So now, there will be questions that will be raised in people's minds as we talk about, as we go through the lecture. And what I would encourage you all to do is to put those questions into the chat, and because at the moment I can't really see most of the chat straight away because I'm trying to present. So towards the end of the lecture, we will gather all those questions, and of course, Madhu is there, and when Madhu is speaking, I will be there. So we will address the questions towards the end of the course, end of the lecture. And the actual course is going to extend around 20 weeks. I'll tell you exactly what the end date is. I think it's January 20th or whenever that Sunday is. And we will have a few short assignments in the during the course, and we have a final assignment towards the end, closer to the end of the course. And we talk obviously the two of us, Madhu and I, being your instructors, your acharyas. Okay, so these are the different topics. Now, we have a lot of topics and a lot of things that we can talk about, and a lot of things that were developed um, by the ancient Indian astronomers. So we will delve on a few things. We will try to delve on cover as many topics as possible within this course, but some of them will be maybe a bit less than the others. So we will talk about first of all the cosmology. So that is one area that we'll talk about, and what I'll try to do there is actually introduce you all to the current level of understanding. Where is the just to give you a yardstick of where the current level of understanding is, so that the all the things we talk about later in the course will be can be looked upon as a comparison. We'll talk about the different um, uh, mentions and the different ancient texts that existed that talked about astronomy. We'll talk about how old the whole astronomy, what were the earliest observations made by ancient astronomers, who were the actual astronomers, what were their works, and of course, I'll talk about not only the entire historicity of the Indian knowledge systems, but it is quite interesting how the Western narratives have actually been almost forced down to us, and they have told us a different story, and we will try again. Everything that we will be doing here again is inspired, taken directly from Dr. Vedam's course, and he is very much very strict on making sure that whenever we talk about anything is backed by evidence. So it's not something which is which is in opinion, but it is more of a fact. So there are quite a lot of other things. So I hope Madhu, yeah, you can your microphone is fixed, and you can talk about the other aspects.
Is my audio better now?
It is slightly better, but not 100%, but it is better than what it was earlier.
Okay, okay. No, I think Ajay, you have kind of covered it well, but I just wanted to add that yeah, of course, we will first because Indian astronomy is a very broad term. There are different phases in which Indian astronomy evolved. So there was a phase when there were just the Vedas and the Puranas, and there are astronomical references there. Then we had the Vedanga Jyotisha era, uh, where there's a significant body of astronomical knowledge that was created. And then we had the age of Varaha Mithila, the Aryabhatta, and this is basically the Siddhantic period, where we had different Siddhantas, of which, of course, the Surya Siddhanta is the most prominent text uh, that has that kind of crystallized all the concepts into mathematical formulas. And then there is a much advanced era of astronomy just a few centuries back. Texts like the Tantra Sangraha and so forth, uh, which kind of deal the subject in a more quantitative and scientific manner, as opposed to the earlier eras where it was more metaphorical and anecdotal. So we will, so I think we will cover the evolution of Indian astronomy across these different stages, and in that perspective, we will talk about the fundamentals of astronomy, such as the concepts of Yuga, Ayana, Masa, the different calendars, the Sauramana calendar and the Chandramana calendar. So and then we will look at how our ancestors observed the skies, right? What was, what were their measuring techniques? What instruments did they use? What techniques did they use to record these observations? How they encoded these observations, stories, and metaphors. And we will also talk about, we will have a brief uh, kind of familiarizing session on some astronomy software. I think we will primarily look at Stellarium. And we will look at it from an application perspective, like where we can demonstrate some of the concepts that we will talk about in Stellarium. And then we, as Ajay talked, we will discuss Western narratives and try to kind of provide a balanced view of how Indian astronomy is represented in the world vis-a-vis the Western perspective. So I think it's going to be so, and then in between there we do have some sections where we will do some mathematical calculations as well, computations. For example, calculation of Ahargana. So it's a mix of stories, a little bit of mathematics, a little bit of history, and a little bit of the Western versus the Indian perspective. So it's going to. So that's why I said it's a very broad-based course covering a lot of areas. The idea is to provide, all the fundamentals, and which will enable each of you to go into deeper in each areas, in a subsequent course. Right? So I think that's the idea. And of course, we will touch upon astrology. It's very difficult not to discuss astrology. Of course, we will resist the temptation not to go deep into it, but then astrology and astronomy are going to be quite equally discussed as we go along the course as well. Right? So I think that's the idea behind the overall course. Ajay, back to you.
Yeah, one of the things, like I said, we have so many different topics to cover here, and so we will try to cover as many as possible, but I think it's important that we, rather than focusing on the quantity, we try to deliver the quality to you. So we will try to provide the specific topics in as much detail as we can. Okay, so moving on. One second, I just lost my screen here. So I noted the comment that some people had about the audio. So yeah, I think Madhu is going to be working on that as well. So what I wanted to start off with was trying to put into perspective what is the current state of understanding of the universe in the Western eyes, which obviously is the prevailing prevailing thought process that exists at the moment. So let's start with the Western concepts. There are the first thing is, what is cosmology? So you are looking at four aspects of the universe, and these are how did the universe actually begin? How is it evolving over time? What is the current structure of the universe, and what is the ultimate fate? So these are the four different aspects that are together in the definition of cosmology. So as you can see, there are only certain things which are measurable, and so you have not only a blend of physics and astronomy, which actually tells you a certain aspects of cosmology, but because you can't really measure the origin, or you can't really say measure or very easily predict the ultimate fate. And so this is this is where the philosophy also comes in. So therefore, cosmology is unique in that sense, that it is a blend of science and philosophy. Now, not too many other scientific aspects or scientific disciplines cover philosophy, because philosophy tends to be a little bit away from science in many aspects. So this is unique from a cosmology point of view. There are different key terms that we need to keep in mind. The universe, obviously, we know what the universe is. There's also going to be mention of cosmic scale. Cosmic scale has been measured in light years, so that is the distance that light travels in a year. So that is one light year. But many scientists, scientific literature these days use parsecs. So parsec is based on parallax measurement of the universe, which is the power part of it, and arc seconds. And I think in the subsequent lectures, we'll talk about arc seconds as well. So in general, one parsec is equal to about three and a quarter or so light years. There is, of course, the whole dark matter, dark energy, and we will talk about that as we go along. One important distinction I want to make here is cosmology versus what is known as cosmogenesis, or in some ways in cosmogony. So cosmology, like I said, is a fourfold aspect, which includes the origin, but also about the structure, evolution, and fate. And therefore, it's got so many different focus areas and empirical evidence and so on. However, cosmogenesis is only about the origin. So many people actually think cosmology is about the origin and not about the other things. But I just like to point out that the origin is really known as cosmogenesis or cosmogony, and that really talks about how the universe came into being. So the current theory, which we'll go into, the scientific base theory, is the Big Bang. But there is also, yeah, I mean, the entire thing is very speculative, and there is clearly an aspect of philosophy, and there's also some stories associated with the origin. So that's a definition of the distinction between cosmology and cosmogenesis. So the current theory that is very much in vogue and accepted widely by the scientific community is the Big Bang theory. And how did it all start? In the early 1900s, Albert Einstein first came into his field theory equations, which includes, of course, or can be summarized in E is equal to mc squared, which is this famous equation that most people know about. But what that did was it gave a completely different definition of space-time. And the warping of the space-time, that warping of gravity and so on. But if that as those aspects taken further, it was shown that what that actually meant was the universe was changing, was not static, was dynamic. And then there was a lot of debate about this, and Einstein actually put a constant, because he didn't believe that the universe was dynamic and changing. It was static. That's what he believed. So in his many of his field theory equations, he actually put a constant, so which actually made the universe not dynamic. And that later on, when the whole Big Bang theory was developed, and it was proven in some ways that the universe is dynamic, Einstein actually said that was one of his biggest mistakes, that he put this constant theory in there. So anyway, taking Albert Einstein's theory forward, and then based on some of his own observations, Georges Lemaitre from Belgium, he actually said that the universe is expanding, and because he almost uses the redshift approach. Even I'll talk about the redshift approach later on, but he said the universe, everything is moving away in the universe, which actually, if you dial back in time, at some point of time they were closer. And what that means is that there was a point where everything was a single point, and he called this a primeval atom. So that was the theory that he put forward. And then Edwin Hubble, a couple of years later, actually started looking at stars and the light that comes out of the stars, and he did a spectroscopic analysis of that light coming out of the stars, and he noted that these, again, using the redshift approach, and I'll talk about that later, he actually said that there is clear evidence based on observations that the universe is expanding, and so therefore corroborating Georges Lemaitre's point that it is an expanding universe which actually had a singular origin. And the actual nomenclature of the Big Bang theory happened maybe in the 50s, when some astronomer, I forget his name right now, but he actually used the concept that the entire thing entire thing was like a Big Bang. So then that whole nomenclature of Big Bang actually became popular. Okay, so what is the Big Bang Theory? According to the Big Bang Theory, the universe began 13.8 billion years ago, and everything was concentrated into a infinitesimal uh, point, and that infinitesimal point had an extremely high density or an infinite density, an infinite temperature, because as you bring things closer to each other, your entropic levels will increase to a point where your temperature will be infinite essentially, and so this theory defines that the universe started from an infinitely hot, dense point, and this initial state went rapid expansion. Now, because of the nomenclature of the Big Bang, it is very natural to think that it was an explosion. However, the current understanding is that it was not an explosion, it was actually an expansion. So there was nothing to explode into, but it was expanding the space that was present in this singularity before the Big Bang. So so that is the distinction between an explosion and an expansion. So now, what happened was because it was so hot at that point, it was not possible for the atoms to actually come together and react. So it was a sea of quarks, and because it was so hot, the quarks could not come together to form an atom. So it was only many billion years later that the atoms started combining. So the first atom that was actually formed, obviously, was the simplest hydrogen atom, which would actually go into forming helium when the two nuclei came together. So this entire thing was called a nucleosynthesis. So that happened much later. So there was a huge period of inflation from that point, and then and this is actually the afterglow, which is the cosmic microwave background. I'll talk about that later. And that led to the formation of the first nucleosynthesis, and then that led to the formation. And as the space expanded, things started cooling. And when they started cooling, they would come together and form these stars, and then, of course, the galaxies were developed and planets later on. So the question is, what existed before the Big Bang? So
Ajay,
yes, sure.
Ajay, am I audible now? Is it better now?
Yes, yes. Do you want to make a
Okay.
yeah, go ahead.
Yes. I just because so the term Big Bang was coined by the British astronomer Fred Hoyle, right?
Yes, yes.
By incidentally, Fred Hoyle was a big proponent of the alternative theory, which is the steady state theory. And then I think in a BBC interview, he actually used the word Big Bang to denote that all the matter that exists today uh, kind of came from that single point in space time, right? Which he coined as a Big Bang. But I also see that this term was really not very popular until probably the cosmic microwave background radiation observations were made, after which the term really took off. And nowadays, it's so much used and misused and abused that we use literally Big Bang everywhere. Even in our corporate meetings, we use the term Big Bang for many reasons which are really not related to astronomy. But the original inventor of that word is Fred Hoyle. I just wanted to kind of make that point.
Good. Thank you. Okay, so I talked about the whole singularity concept, and there it is almost like, at the point where the universe started, it was defined as being an infinitesimal point with infinite density, infinite temperature, and so on. So that is the current consensus. However, I think many people talk about this singularity as a idealization rather than a physical reality. And so it is what is considered also to be a theoretical boundary at which the laws of physics actually break down. So there is this concept of quantum gravity that needs to be able to describe this point. So the question about what actually happened before the singularity, was there before, is what is being is something that is kind of being debated in the scientific world. Okay, so then we talk a little bit about this redshift. So what happens in the redshift? If you look at the spectrum of light, the visible spectrum, you see that things with a higher frequency. So if you look at the frequency of the wave, the wave with a higher frequency gives you a certain high energy. So, for example, all your lights and microwaves, for example, they will be in the blue area. And as your frequency diminishes, you tend to get a expansion of that wave into the red zone. So this is, I'm just talking about the visible spectrum. So anything outside the visible spectrum, like the UV and the gamma, or the very low frequency radio waves, you can't actually see, but this is only the visible spectrum. So when Edwin Hubble observed these galaxies moving away, what he did was he took the light from these distant stars, put them through a spectroscope attached to the telescope, and then he saw that most of them were actually increasing, going towards the red area, and therefore he surmised that this was indeed the red shift, as he called it, or as it's known now. So this is almost like, you can think about it as a Doppler effect, where something that's moving towards us will actually increase in frequency, and moving away from us will give you the longer or the red wave. So that is the Doppler effect. And from there, he postulated this law where the velocity is equal to a constant, which he called the Hubble constant, or which is known now as the Hubble constant, and times the distance. And the Hubble constant or at the moment is about 70 kilometers per second. The part-second ratio. So that is the Hubble's law. But however, this is a little bit in the constant itself is still under discussion. So the other aspect that is giving credence to the whole Big Bang theory is the presence of microwave background. It's known as the cosmic microwave background, um, and it is essentially in the 60s, I think in 1964, that two astronomers actually pointed to different parts in the sky and constantly got ecstatic. Uh, these two astronomers said, okay, there must be something inherently wrong with the measurement. So they kept on looking at different areas, and they kept getting the same static. Now, it was then confirmed that this static was actually the result or almost like a leftover radiation from the expansion that occurred 13.8 billion years ago. So that was that is something that you will find across the entire universe, and there are many satellite images now that can actually pick it up as well, and it is it is essentially, if you look at the beginning of the universe, it is the point where the certain radiation which was trapped by the high temperature and could not escape because of the number of quarks and atoms that were present initially. And as the space expanded, this radiation escaped and now populates the entire universe. So another aspect which actually helps to look at the cosmos and the entire how large this cosmos is was when a telescope was launched outside the atmosphere into an orbit of the Earth. And the entire advantage of having a telescope that is outside the Earth's atmosphere is that it allows one to actually look at galaxies and stars in a much more precise manner, because the atmosphere that we have protects us from many of those different radiations, so we can't even pick up some of those areas. So this is one of the first images coming out of the Hubble, and that actually said how big and how vast this entire cosmos was, and that also helped to corroborate the Big Bang as well. So the next a couple of slides, Madhu, you want to go through?
I will, but in case my audio is still a problem, Ajay, I can ask you to take over.
Yeah, sure. No problem. Go ahead.
Sure. So obviously, the James Webb Space Telescope was launched, a few years back, right? And the primary goals of the JWST was to search for light, from the very distant and the first galaxies that formed right after the Big Bang, and to study how these galaxies formed and evolved over time, and also to understand how the stars and planets evolved as part of these galaxies, and to study the exoplanets and also the origins of life. So these are the primary objectives of the JWST, right? And uh, so what? So the major leap from Hubble to JWST was the fact that the JWST is infra red based, which means it can actually peer into parts of the cosmos that the Hubble was not able to, right? And yeah, so sorry, I can see some.
No, sorry.
Yeah, sorry about that. So, so I think infrared astronomy was the the uniqueness about the JWST. Uh, so, so it's now able to provide a much deeper view of the universe. So, for example, if the Hubble was able to look at say 1 billion or a few billion years in the past, the JWST actually is able to reach out to almost what is now we call as the origin of the universe, right? Just the 13.7 billion years, right? Uh, so I think it kind of provides a very giant leap in our understanding of how the cosmos was formed, right? If you go to the next slide, Ajay. Uh, so you can see that the redshift data that's provided by JWST is really enabling us to look at the most ancient times and the most ancient galaxy formations and able to gather a lot of information from them. This is also a very famous image from the JWST, which is the deep field SMAX 0723, which is the deepest view of the universe yet, right? And, that's right. So, uh, so essentially, it's able to provide a very, it's able to reveal galaxies that were never seen before, including very young galaxies that were formed only a few 100 million years just after the Big Bang, right? Which was not seen before. And it is also able to, because of the resolution that it has, which is very high resolution that it has in comparison to Hubble, it's able to produce images with much greater depth and clarity compared to the to weeks of exposure that Hubble would actually take to provide an image, right? So the hope is that it will give us clues towards how the universe evolved and will hopefully be the foundation for the future discoveries as well, right? So now the point is, how does this relate to Bharati astronomy, right? See, because uh, we are almost going to the beginning of time, right? Or the beginning of space time, and trying to understand what happened during that. And the JWST is actually getting where us much closer to that point, right? Now, this is exactly what Bharati astronomy also has attempted to do, in all the in all the knowledge systems that we have is uh, to understand the idea of the infinite, which is the Ananta, right? And uh, the evolution of time, or what is the concept of time, how time evolves, right? Or the eternal cycle of time that is kind of represented through the Mahayuga cycle that we will also see. So, in effect, whatever the Bharati astronomy texts have tried to explain through their different stories and metaphors and verses, JWT is actually enabling us to get closer to understanding that, right? So this is where it kind of connects with our Indian astronomy as well. So I hope in the future we'll be able to get much more observations that will further solidify what our ancients knew and wrote about the origins of the universe, right? So yeah, I think that's the power of JWST. Over to you, Ajay. Back to you.
Thank you. Okay, so then there's also one aspect of how does the universe end? What is the so we talked about the Big Bang, which is the start of the universe. Madhu will go a little bit further into trying to understand what the ancient Indian uh, time Kala system tells us about where we are, what is the present point. So what is the final future of this universe? And So at the moment, the entire expansion of the universe is fueled by the what is known as dark energy. So there is no clear understanding of what that dark energy is. However, there is clearly an expansion force which is accelerating almost this expansion of the universe into this or expanding the space of the universe. So will there be a point where there is going to be a sufficient gravitational force that will actually overcome this expansion force, overcome the dark energy? Or will the dark energy also run out of fuel at some point? So we don't know if that is going to happen. So it is currently, there is also this ratio of the matter density, which is said to be less than 0.3 at the moment, and it needs to be greater than 1 for the gravitational force to take over. And if that does happen, then the speculation is that there might actually be a big crunch. Now, that actually leads us to another theory, which is known as the big bonds theory. And what that theory tells you is that you had a series of big bangs, and then you don't have a big crunch, but you have another. You have a contraction of the universe, the shrinkage of the universe that actually leads to another big bang. So and therefore you don't have a real singularity as such, but you have a repeated bonds. Now, one of the reasons I wanted to bring this forward, and this is still a theory that is not very widely accepted, and that is, of course, one thing about science is that any theory is first completely denied, which actually happened with the Big Bang as well. So we never know that in another 10, 20, 30 years, this might be a theory that actually is more prevalent. However, I think one of the things is that it corresponds quite well to the different aspects of the ancient Indian theories, Bharateeya theories of the continuation of the cyclic nature of the universe. Now, that is one of the biggest difference between the Bharatiya models and the Western theories and Western models, is that they tend to be much more linear, the Western models, whereas the Bharatiya models tend to be much more cyclic. And in fact, cyclicity is supposed to be inherent in everything we do. So there are a number of open questions within the cosmology today. What is the nature of the dark matter? How does dark matter is the fact that we cannot identify almost 90% of what is in the universe. So that and what is this energy that is expanding this universe? So it's been, because it's not known, it's been called the dark energy. So we don't know what the nature is. What happened before the Big Bang? Was there a singularity, or was there the cyclic nature of the big bonds that I talked about? The Hubble constant, that is a pretty much ever changing. So Hubble came up with a number. There have been differences over the years. We talked about the fate of the universe. So there is also this multiverse hypothesis. Now that actually corresponds well to the Bhagavad Purana definition of the universe. So we'll talk about that. And there is also the whole matter antimatter question, but we won't go into that at the moment. So these are some of the different references that we have that I use. I actually read a few of them. I've read snippets of the other ones, but these are there if you want. These two are very good websites, the NASA website and the European Space Agency website, which can actually tell you a lot, give you the current events and images that the telescopes have captured and so on. So then we come to maybe just a couple of questions that we can think of in this trying to reflect, trying to understand what this. If you want, you can take a screenshot of this. We will, of course, put the recording on, but the recording, I don't know how quickly it'll come. That you can access it, but you can definitely take a screenshot of this. This will be the first assignment and a short one, but at least just trying to reflect on what we talked about today. Maybe if you want, you can go through some of the references. And again, if you want to take a screenshot of the references, you can do that as well. And these are the questions. One is trying to reflect on the Big Bang, on the origin of the universe, and then trying to think of what actually is expanding and why either big bounce or big crunch might be the way that you can think of. Or if you think it's not necessary, that's absolutely possible as well. Okay, so that is our lecture for today. Is there any? Oh yeah, Madhu, you had something?
Yeah, I just wanted to add something very relevant to the different models that you talked about. So of course, the Big Bang model is the most widely accepted theory. However, there is something called as conformal cyclic cosmology, and I would encourage you to kind of look it up and read about it. It was actually formulated by Roger Penrose, who is a Nobel Prize winner, but not for this theory, right, but for something else. So what he says is that the universe, so his theory is that the universe goes through in cycles, very much like what Indian astronomy also alludes to, right? So he says that the universe goes through different cycles, and these are endless cycles. He calls them as eons. So each eon begins with a big bang, and then it ends in a cold, empty state. You call it a big crunch or whatever, where only a very small amount of radiation remains, right? And then that kind of becomes the seed for the next big bang, and this is an endless cyclical process. So I just wanted to bring this point out to say that there is a branch of modern astrophysics that does subscribe to the cyclical nature of the universe, not only theory. So there is so there are some, so hypothetically there are some points called as the Hawking points, right, which Roger Penrose has theorized that they do exist. So these Hawking points are nothing but evaporation caused due to evaporation of supermassive black holes from a previous universe that are kind of what you call smoke signals in the current universe, right? So he has actually, so he actually says that to support the cyclical nature of the universe, you could actually uh, experiment, experimentally and observationally look at these Hawking points, which kind of form the basis of that. It has not been proved yet, but it's a theory. Uh, but I just want to kind of bring that. If you are interested about learning it, I would encourage you to learn about CCC, which is conformal cyclical cosmology theory by Roger Penrose, which is the kind of closest to what the Bharateeya Astronomy texts also are doing. Back to you, Ajay.
Good, thank you. I think there's a question from Mahesh about whether we are going to share the slides. So, yeah. So, Madhu, do you know how you, because there is supposed to be a folder for the.
Yeah, so that is something that we need to check with the Asha Seva Kendra. Definitely they'll be shared, right? I mean, I don't know if it will be shared on I don't know, on a per class basis, or do we share it at the end of the course or somewhere in between? That is something we need to work out the details of, but definitely the content will be shared. And of course, with the caveat that in case you are using it for your own work, you provide the right references to the work that we have done here, and that's the minimum that we are kind of asking for. But it will definitely be shared. But Ajay, maybe what we can also do is just share the weekly assignment slide so that people can
Yes.
people can actually know what that assignment has kind of worked towards it.
Okay, that's fine.
I will definitely share the slides.
I
Yes.
can share the assignment slides on email, and then what you can do is get back to us on email as well with your answers or whatever.
Yeah, thank you, Ajay ji. The reason I said was that to do the assignments, we may have to refer back to what was told.
Okay.
And so it'll be good to have that. So suppose you give everything at the end of the class, I'm pretty sure that people will park it somewhere.
Yeah. Okay.
So
All right.
we'll have a chance to go through and refresh.
Okay.
I mean, I'm looking at purely from personal use perspective. It's not for republishing or anything like that.
Yeah. Yeah. Sure. Any other questions? Okay. So
Another suggestion is one of the things in another way we have done in the past is that Asha Seva Kendram has a Google Drive, and you can create a folder and post there. That way you don't have to populate so many people's inboxes.
yeah. Okay.
One link you send it, and people can, and if at all there is an update you need to do it in only one place, and everybody will get it.
Okay. Sure. I'll check
Just a suggestion.
I'll check with Narayan on that. So I'll come.
Yeah.
Okay. Sudha, you
Yes.
had a
For the assignments, do we send it to you via email or do we send it on WhatsApp?
email will be better, I think, because of WhatsApp, it tends to get a bit lost with and small screen as well. Any comments, Madhu? You think email is better or WhatsApp?
I mean, either way is fine, Sudha.
Yeah.
So I think more important is to actually do the assignment. I mean, the only thing with WhatsApp is people will get to see your assignment before they actually do it.
Okay.
So you can probably message it in private to Ajay and myself.
Okay.
So
Yeah.
that or you can find the
Madhusudanji, when Jaykumarji took this Lata and Sasyam and other classes, I don't know what he's doing now. I mean, I don't think he's taking any class. But anyway, those days, I'm talking a few years ago, he used to have homework pretty much every day. So you write it on a piece of paper, things, and scan it and upload it, goes back to the say something like a classroom or somewhere in the Google Drive. So you also can look at it. And if you want to make a correction and make correction and send it back to us.
Definitely. Yeah. We don't see, again, we don't want to make the process very strict to the extent that it
No. I'm saying is,
from,
the advantage is everybody's response will be in one place rather than in WhatsApp in so many places or in email so many places. That's my point.
Sure. Thank you. Yeah. We will also check back with Narayanan how what
Narayanji
handled.
actually those days Narayanji and maybe another gentleman by name Vijayji was also doing it. There were several people, but the idea was that everything was put in a Google Drive, and Google Drive has got a lot of things like Google Classroom, Google Class Notes, or whatever, and that's what it was done. I don't know whether that is being practiced now, because for me that is
where yeah,
years ago.
Yeah,
but
that is where.
Having said that, a lot of our activities we are doing in terms of sevas, whether a lot of them are in, almost all of them are in Google Drive. And the reason also is that Google Drive, there's a drive to make it more secure, more so that private and things like that. So you please talk to Narayanji and he will probably able to guide you the right way.
Okay. All right. So we'll meet again next week, and same time, and we'll talk a little bit more about the Indian cosmological models. Okay.
Thank you. Thank you, Ajay ji. Thank you, Madhusudan.
Thank you. Thank you all. Bye.